This is number 10 from the review problems. This is a circular motion problem. So a 500-gram ball swings in a vertical circle at the end of a 1.5 meter long string. When the ball is at the bottom of the circle, the tension in the string is 15 newtons. So we have to draw a Freebody diagram and label our coordinate axes, and we have to determine the speed of the ball at that point. So we'll write our givens and finds. We have the mass of the ball is equal to 500 grams, so that's 0.5 kilograms. And we have our radius is equal to 1.5 meters. And we know the tension is equal to 15 newtons. And we're looking for V, the speed of the ball at the bottom of the circle. So we'll draw our picture. And this is our radius, and our ball is right there at the bottom. And we'll first do our Freebody diagram. So A, Freebody diagram is tension and the force of gravity. And notice, because the ball is moving in a circle, that there's a net force towards the center of the circle. So therefore our tension needs to be bigger than our force of gravity. So that's A, and we have to talk about our coordinate systems. So we're going to call up positive. So we're going to say in this picture, up is positive. And that's really all we need to say, because we're looking at it at this point right here. So this is really the R direction towards the center. And around would be the theta direction. But in this figure, we're just talking about it right at this point. So our up towards the center is going to be positive. So the next thing we're going to do is we need to find the speed of the ball. So we need to use a Newton's second law. So we're going to do the sum of the forces is equal to ma. And because we're working in a circle, this vertical circle, we know that this is equal to mv squared over r. And so what are our components of the forces? Just take them right from our Freebody diagram. So we're going to say T minus Fg is equal to mv squared over r. We're going to plug in, T minus mg is equal to mv squared over r. Now we're interested in V, so I'm going to multiply both sides by r over m. So I'm going to do r over m times T minus mg is equal to V squared. So V is equal to T minus mg times r all over m. And then I'm taking the square root of that. So if I want to plug in, V is equal to 15 newtons minus 0.5 kilograms times 9.8 meters per second squared times the radius, which is 1.5 meters, divided by 0.5 kilograms. I'm taking the square root. So the velocity is equal to 5.5 meters per second.